So first lesson, minting with a validity interval. So a couple of prerequisites. In order to follow along with this lesson, you'll need a Cardano node, and you can run it locally or on Demeter.run as shown in lesson 102.1. Okay. I do have a node running locally, so I'm going to be able to demonstrate these examples on this computer. But if you don't have a synced pre-prod node, as you've seen, Demeter Run is a great option, and all of these scripts will work there. You should also have completed module 202, and we're going to assume some background knowledge. So module 202 was where we just minted some basic tokens by several different methods with Game Changer, with Cardano CLI, in the front end UI of a web app using Mesh. And then we explored a little bit about minting with a validator. So what we're able to look at is that there are some transactions. Okay, and those are only in the example, which I'll open up in just a second. So yeah, we're about to look at a transaction example that if you've already worked through module 202, it'll look familiar. Okay. What we're going to do, we're going to mint a native asset that can't be minted again. One way to make a token non-fungible is to guarantee that it can't be minted again, right? And so we have this concept of a time-locked minting policy. And in order to demonstrate this, I'm first going to run some provided scripts. We're going to create a new minting policy, mint a token with it, and then we're going to wait a few minutes until after a deadline, and we're going to try to mint it again. And we're going to see that we can't. While we're waiting, we're going to come back to some of these examples together. But I wanted to jump right in and run this script, investigate how it works together, and then show that after the deadline, it no longer works. So let's jump over to here. So I have the PPBL 2024 transaction examples repo on this computer. You can clone it as well from the link provided in the course. I'll pull the latest changes to make sure that I have them. In this case, I'm already up to date. And you can see I have some untracked files that all relate to new scripts, new signing and public keys, a currency symbol. And the scripts we're going to run right now are going to produce more of the same, okay? All of the examples we need here are in the module 203 directory. So let's jump into there. And the one we're going to start with is this one, Mint Time-Bound NFT. Let's take a look. So there's a few things to notice here. One is that this is calculating a current slot by making a query tip call to Cardano CLI. The other thing is that there's two ways to set your address and signing keys. One, excuse me, one is to open up, or in your case, probably create a new env.sh file. I'll show you an example of mine in just a moment. Or you can just uncomment these two lines right here by deleting the comment symbols. And you can add an address. Sender is an address, and then the path to your sender key. I'm going to show you what these two look like right now. You can see that I have an env.sh file. This is included in the git ignore, so you won't find it in the repo. And if you make your own env file, you don't have to worry about that getting accidentally pushed up because once again, it's already included here. But let's just take a look at it. So I'm doing two things right here. I have a sender address, like I just mentioned, and then the path to a signing key. And if this wasn't on pre-prod, it would be irresponsible of me to be sharing my screen like this, right? I'm here on a computer that's hooked up to Zoom and I'm showing you the path to an S key. If you were a smart hacker, you could just jump into my machine, take this S key, and that's just like me exposing my mnemonics to you. Okay. Um, in this case, I'm fine doing this for demo purposes, just with the caveat that I'm using a testnet address, and I would never do this if this was a mainnet address. So we've got this file set up, and let's go back and look at right here, this dot, right? This dot is pronounced source. So what are we going to do? We're going to source the env file, and then we're going to source a utilities file that has a couple of helpful functions that we'll use later in this transaction. Okay. But I said we were going to run this first. And what we need in order to run this is just an address to receive the token that we're going to mint right now. You know what I'm going to do is off screen, grab the address from my pre-prod wallet that's hooked up to Eternal so we can look at the results of this. So I'm copying this. And now to run this script, right, which you can do even if you're not even sure how everything works here. We're going to look at this in just a minute. But as long as you've got the sender and the sender key loaded in, you should be able to run this script as follows. Right? So so dot slash means run this script. It is executable right here. Let's mint a time-bound NFT. And remember, it took one command line argument, that $1, which is the address to which we want to send this. Oh, and of course it didn't work because it's a demo. Let's see. All right, that's wonderful. Get address biggest Lovelace. Okay, that's good. The reason this happened is because get address biggest Lovelace is in this file right here, utils.sh, which is actually in the same directory as the script I'm trying to run. Let's fix that. I want access to this function right here, but if I look at where I'm sourcing utils from, it looks like it says dot dot for the parent
Nice.
directory. So let's change
Easy,
that. There we
easy
go.
fix.
Easy
Yeah.
fix, right? So let's try that again. There we go. All right.
Okay.
So I didn't plant that error, but I wish I could take credit for
I
that. It's a
I
nice
wish
one.
that you did. Hey James, would you mind bumping up your font just a slight bit?
Oh, you
Is
got it.
that
Yeah,
is that too
no problem.
yeah, nice. Wonderful.
All right, so this prints a couple things, and now we're on the clock because we just grepped, we just grabbed the current slot of the blockchain. We did a little bit of arithmetic to create a deadline slot. We're calling this token just the deadline itself, okay? And we're going to talk about this number in just a second. And then we see that the transaction built successfully because we see the transaction fee. And then we see that it was signed and submitted successfully because of this message right here. Both of these are coming from Cardano CLI. These three messages are coming from the script that we were just looking at. Now that we're on the clock, and this thing shouldn't work again in, well, how much time is that? Let's look. So once again, this was mint, and no, mint, time bound. Okay. So what happened here? We ran a command so that we could see the tip of the blockchain. And maybe you're already familiar with this. Over here in the lesson, you can see an example. Let me just pull that right back up for a moment. So when we query the tip of the blockchain, we might see a response that looks like this. And in our script, we're pulling this bit right here, which is the current slot of the latest block at the tip of this network. Okay. And this number right here represents the number of seconds since the blockchain started running. It's a protocol parameter that a slot has a duration of 1 second. And that is a parameter technically that can be changed. I'm not sure if that's likely to ever happen, for example, on mainnet. I'm not aware of circumstances that would drive us as a community to say that a slot should be something other than a second, but theoretically it's possible to change that parameter. And I'll leave it to you as some arithmetic to figure out when the pre-prod network started. You just turn this number of seconds into years and you can figure out that date. What we're doing is we're just running that command, and then we're using a tiny application called JQ to pull the value of slot from right here. Then, once we have that number, we do a little bit of arithmetic. Right? We say, okay, just print that to the terminal. We just saw this on the screen. And then add 900 seconds, which is equal to 15 minutes to calculate what we can call a deadline slot. Because this is just an example, that's going to be the name of our token. So we make a new directory with that name and we change directory into it. Then we create a new set of keys just for this minting policy. We calculate the key hash as you saw in module 202. For all of the files that are created, we use this variable right here in the file names so that if we run this script multiple times, we'll be able to distinguish between the different keys and scripts that have been created. And then we use a nifty little feature of Bash right here, which allows us to echo, which just means print, in between some quotation marks, an object. And then we save this object into a new file name that we've already defined up here. What goes inside of that file is a script that in previous lessons you've learned how to write by hand, but I think you're ready just to have a script like this automatically generated. The one thing that you might notice are all these slashes right here before the quotation marks. That slash is called an escape character, because think about it. We have an opening quote here and a closing quote here. We don't want the script to think that we want to stop the quote like right here, right? So what we do is we put a slash and then a quotation mark, which actually prints the quotes into the file that we're building. And I'll show you that in just a second. Okay. Escape characters. That's a really nice thing to know about if you're writing scripts of your own. Once that script is generated, we use it, right? This variable right here is exactly the same one we're passing right here. Let's use Cardano CLI, transaction policy ID, pass it this script file, which is the only parameter it requires, and save that to a new file called deadlineslot.currency symbol. And that's the policy ID that we're going to mint. Finally, just some helper functions right here. Get address biggest Lovelace. That's the function that we couldn't find when utils wasn't properly imported up here. But all this does is it looks at the address that we've already saved as sender, and it grabs the biggest Lovelace only UTXO that's currently at that address. All right. We can look at that script together if it's helpful, but first I just want to take it the rest of the way through here. The other thing to notice is that when we have a token name and we're using it in a script like this, we can't just use a number, right? So deadline slot was some slot number. It was an integer, but we convert it to a hex string. And if you've been working through the course, maybe you've seen that there's websites that do this, like stringfunctions.org. But we're just going to use a simple bash function right here. Okay. We're going to take some variable. What variable? Deadline slot. And we're going to convert it into hex. We save it as that. And then the token hex is actually the name that goes on chain, right? It's not the name that you'll see in your wallet. If you look at this token on Cardano Scan, in Nami, or in Eternal, all of them take that hex string and they convert it back into a legible string, which in this case will be the slot number. But you can see right here, now that we've prepared all these variables, here's our transaction build. This looks pretty similar to what you've seen early in the course when we were building simple transactions, and more recently in module 202, where we were minting. It adds one key line right here, invalid hereafter. And what this says is we're going to build a transaction that won't be valid after some slot. Why? Because that's the rule we set up in this script. In this transaction, we're trying to mint a new token. To mint this token, we have to satisfy these two rules. It has to be minted before the deadline slot, and the transaction needs to be signed by this new signature associated with the pub key hash that we generated right here from the V key we generated right here that is associated with this signing key. So notice that both of these rules require us to add some information to the transaction build. Hey, I want to mint this token. And I promise the transaction is going to be signed by this signing key, and it's going to be invalid after this deadline. Okay. As long as I meet those two constraints, then this will build successfully. I'll be able to sign it and submit it. How does that feel to everybody?
Hmm.
While you're thinking about questions, I'm going to open up the results of all of this. So let's jump out of the script itself. Whoa. And let's see what was created here. Okay. So first of all, you can see there's this new directory with the name of this token. Here's another new directory. This was the failed transaction. So some of the beginning of that script happened. And if I jump into that one, 9523, I will see that the transaction never happened. We created some keys, we created a script, but when we went to build the transaction, the build step failed because there was no UTXO input because we had a function that wasn't imported correctly. Let's compare that to the other one, 9605. Right. This one actually has the draft of the transaction and the signed transaction right here because it worked. And now let's run this function, query tip testnet magic 1. And you can see that now the chain is currently on slot 6666 9358. All right, we're not here yet. So it would still be possible to mint more of these tokens. Remember, let's just put that up on the screen again, but let's also open up the script. Mint time-bound token, right? This has to be minted before this deadline, which we haven't hit yet, with this key hash, which is the hash of this V key right here. And Oops, I want to cat that PKH. Oops. Let's that's kind of annoying when that happens. The solution is to do it like this. There we go. Now it's on one line. Okay, so here's that pub key hash, and it's exactly what's in this script right here. Good enough. Um, are there any other outputs that would be helpful to review here to make sense of what's happening?
Outputs from the,
Like any of these guys or
oh, I see.
details of the
Oh,
script that we were just looking at?
yeah. Show me again where the key hash goes in the transaction build.
Beautiful. Okay.
So,
Okay. So after we make the new directory, we just generate some keys, right? Which is wild. This part's wild to me, right? Because if you're holding actual assets on Cardano mainnet, these two things are so uniquely important to you. But they can also just be created over and over again and thrown away. And right, there's it's hard to estimate the scope. Thousands, millions of key pairs have been created and never used on Bitcoin and Cardano. Right. So
okay.
we generate a throwaway set of keys, and then we say, okay, now given that we just created a verification key file with this name, let's use that as the input to the next command, key hash, and generate a new file called same name, but with the extension .pkh. So now we have the key hash. And where is it used? Okay, once we have it, we're going to use it right here in the minting policy
I
script.
see. Okay. Okay.
This can all be done by hand as well. And right, as an exercise, um, this is something for us to talk about just like philosophically as we continue to build out any course material is what's the right amount of copying and pasting or just writing by hand new files to ask people to do. Right. So we're not asking anybody to do that here, but optionally, that might be a nice way to kind of build a little more hands-on muscle memory. And the experiment here is to figure out how to strike the balance.
So it takes all of that and then builds. So if you scroll down and does it take it? Is that the only place that that key hash is used? Yeah, because
So
it just builds this
yeah,
PKH.
in
But
terms
then,
of the key hash, it is, but once we include this bit right here, we're
mhm.
locked in to saying two things. One, that in the build, this transaction is going to be signed by this signing key. Which signing key? The one associated with this pub key hash, right? All of which were created up here. Key gen, create the V key and the signing key. Key hash, use the public key to make the public key hash.
Oh, I got it. Yeah, yeah.
Then, right, this thing, right, this is the public thing. I can share my verification key or my pub key hash or my wallet address with anybody, but I can't share the signing key.
Hmm.
All right, to mint these tokens, we promise we're going to use the signature associated with this pub key hash. Don't believe us? Well, the pub key hash is public. Go look at it. And once you see it, you'll know that we've got the signing key right here. This line is not always necessary in a simple transaction. Why? Well, down here, you can see there's two signing keys, but only one required signer. This sender key right here is required because of this TX in right here. So if we're going to spend some UTXO, it's implied that we're going to have to sign for it. But separate from that, oh, for the minting part, yeah. There's going to be another signer. And here, we'll provide that signing key as well. You could have many of these in a minting policy. Then it would be a multi-sig minting policy. And there's more examples of that in module 202. Right? And if I had multiple required pub key hashes, I would just add additional required signers here and additional signing keys here. Oops. So are we getting close to that deadline? Oh yeah, looks like we're beyond it. Great.
Ah,
Okay. So enough seconds have passed. Now,
oh,
here's where it gets interesting, right? It's kind of nice to be able to and we'll go back and forth. Okay. So what I'm gonna do here is what's the best way to do this? I want to use all of the same variables we were using a minute ago um, to show that I can build this transaction again. Um, and the way we're going to do this is as follows. Let's open a new tab and just throw this right here. And then I'm going to pull in these variables. I'm going to do this by hand, actually. Some of this I'm not going to have to specify again. Well, yeah, I'll just do it all. Here's why. So we're going to need a TX in, a receiver address. Quantity is one. Um, Policy ID, token X, mint
uh,
script file path, deadline, slot, and we've already got sender loaded in, I think.
yeah,
Mm,
you're just going through all the different
yeah,
variables.
so I'm going
And
to grab all these because this script right here automatically generates new ones. What I want to do is reuse all of those,
yeah,
okay? So what were they? Well, we need we're going to come back to that in just a second. We need the policy ID. Oh, it doesn't autocomplete. All right, we're going to need that policy ID. We need the,
It's because the script will generate if you use again the script. The script will generate updated conditions. And one of those is
Exactly.
the time slot, right?
Yes. Yes.
What you
But
want to do, and yes, what you want to do is what you are doing is recreating the previous conditions and test that previous scenario, right?
correct. Correct. But there's something really interesting that happens here that's unusual if you've been following with some of the examples before. Receiver address. Do I have sender locked in? No, I don't. Okay, let me grab that. Uh, Here's my sender address, which I'm also going to use as receiver address. Okay. And let's query this one. Um,
So for our students watching this video, just pay attention to this process because that's the process you have to do if you want to recreate again a previous scenario.
Here's a nice big UTXO. This would be my greatest Lovelace only UTXO if I was using the utility script. And it was at index 1. Okay. And then some token, the token name can actually be anything. I'm just going to make it 4444. Fine. It doesn't, that token name doesn't really matter. There's nothing validating there. So now if I take all of these variables and I drop them into my terminal here, oops. Oh, you know what we're going to do? Why can't I paste that? Copy. It's not defined. Well, let's do this. Can I do it now? There we go. Okay, so set those variables. The transaction build, oh, let's do it correctly, is going to work. Oh, except that that script doesn't exist. What's the name of the script? Oh, I'm not in the right directory. Right on. Let's go into module. I was working from here, right? And then I have to go into here. There we go. All right, let's paste that again. This transaction actually builds. It's a valid transaction. Why? Well, because we specified some rules in the mint script file. And then we followed those rules. We built a transaction where the deadline slot matches what was in the script file and where the proper required signer is here. If I change that deadline slot to a number that's greater than the deadline here, so 9,700, right? If I change that deadline slot and then I try to build this transaction again, No, it still works anyway. Okay. Because it's not confirming at this stage. I thought that was going to fail because this didn't match this, but it's not exactly like um, it's not the same thing as a validator script. I'll explain more about that in just a second. So let me go back. This once again, I just repeated this transaction right here. This should be valid. Where the failure happens is not here. And it's not here either. I have sender key set up, but I have mint signing key file path set up. I just need to enable my sender key. Let's pull this over here while we're here. So we're also going to be able to sign this thing. Oh, let's do this correctly. And let's go back into that directory. So we have a draft of the new transaction in here. There's our new draft. Let's try to sign it again. The way we sign it is like this. That part's okay too. However, if I try to submit this transaction again, I get a really nice new error. Error while submitting transaction, UTXO failure outside of validity interval UTXO. Okay. We needed to be before this slot as specified here, but the current tip of the blockchain is here, meaning that even though we could build this transaction again, the blockchain won't accept it, right? And so if you can replicate this by minting some new asset and then showing that it's impossible, you'll have completed this lesson. And so the rest of the documentation is here, and we've gone through step by step here, right? We have a Cardano node running. I showed you how to pull the latest changes. We inspected this script file. We talked about how to set sender and sender key either by hard coding them or starting to use an env.sh file, which is a really nice best practice to be aware of. We ran it and it worked. And then we ran it again after the deadline and it didn't work. So you could try the same and repeat these steps like I just showed. Now, that might be an NFT. You can find this policy ID on preprod.cardano scan, and you won't be able to mint it again. Very exciting. Okay.